Hello students, today in the gravitation part 4 we'll start with the next topic. In last topic of gravitation part 3 we learned telescape velocity. So today we are basically going to talk about weight and mass, and then we'll continue ahead with few sums numericals which are given in your textbook at the behind. So we'll continue with today's lecture, students. Here, before I'll start with the mass and weight, we have already studied in our lower standard that matter and materials. Matter is everything around us. All the living and non-living things are made up of matter. Matter can be in three states: solid, liquid, and gas. So here when we are talking about matter, the amount of matter in an object is called mass, students. The amount of matter in an object is called mass. So here, students, when we are talking about mass is the amount of matter. Mass is a amount of matter, and this amount of matter never changes, it remains same. So it is same on each and every earth, planet, every planet, and not only every planet but also everywhere on earth, students. Let's move ahead, students. But when we are talking about mass, mass into acceleration due to gravity, is called gravitational force, and this is nothing but weight, students. This is nothing but weight. So I'll define weight is nothing but a force of gravity, and it is denoted by Fg here. G for gravity, students. G for gravity. I'll repeat again. Weight is another word for the force of gravity. This is nothing but force of gravity, students. Here, now you'll say F is equal to mg. How F is equal to mg? Students, we have already studied F is equal to ma in your 9th standard. Here a, instead of a we are using g, as g is the acceleration. Here acceleration is due to gravity. Whenever any object is pulled towards down, that means it is pulled towards the center of the earth, and this is because the gravitational pull, and that is the reason why the acceleration a is replaced by g, students. Acceleration a is replaced by g because acceleration is due to gravity. Now here our formula is F equal to mg. This is nothing but weight. This force is nothing but weight. So what is weight? Weight is the force. Weight is the force of gravity. Weight is another word for the force of gravity, students. So please remember weight. Now let's see the difference between mass and weight. Mass is the amount of matter contained in a body. Weight is a force with which the body is attracted towards the center of the earth. Now here we are having definition. Here this is weight is a force, mass is a matter, amount of matter. Now when we'll talk about unit, mass is having SI unit kg, and SI unit of weight is Newton. Force is having SI unit Newton, so weight is also having SI unit Newton, students. Mass, when we are talking about mass is the amount of matter. To denote it, to explain it, we don't need any direction, only magnitude is enough. So here mass is a scalar quantity, whereas weight is a force, and this force is always directed towards the center of the earth, and this is the reason why this is having direction, and this is a scalar quantity, sorry, vector quantity, students. This is a vector quantity. Now mass it remains constant at all places. Mass remains constant at all places, whereas weight changes place to place. Now you will say why weight changes place to place. When you will see last slide, mg, force is equal to mg, that weight is equal to mg. Here mass is constant every year, but g value changes from place to place, and not only place to place, when you will move away from earth's surface, g value changes. So as g value changes, the weight also changes, students. The weight also changes. So here it varies from place to place, weight varies from place to place, and mass remains constant at all places, students. Now mass of a body is never zero. Mass of the body is never zero, whereas weight can be zero, because we know that g can be zero. G is zero. Here in this formula of weight, mg is there, g varies and g becomes 0 at the center of the earth, at the center of the earth. So here g becomes 0, that means weight also becomes 0. So weight of the body becomes 0 at the center of the earth, but mass of the body never becomes 0. Mass is constant, students. So this is the distinguish between mass and weight. You will able to come to know the difference between mass and weight, students. Now let us continue with the few sums which are given in your exercise at the end of the chapter, students. Here one question is given that the let a period of revolution of a planet at a distance capital R from a star be t. Here period of revolution is given t, students. Period of revolution is given t and distance is r, students. Prove that if it was at a distance of 2r, instead of r we have to take 2r, the star its period of revolution will be root 8t. So students, when distance is equal to r, the period of revolution is t. This is given to us, and what we have to prove, that when instead of r we are having 2r, distance is 2r, the t value must be root 8t. This we have to prove, students. I'll repeat again, students. I'll repeat again. When you will read this question, you will come to know that the distance is r, and when distance is r, period of revolution is given t. When distance is r, period of revolution is given t. And here we have to prove that if distance is equal to 2r, if distance is equal to 2r, the period of revolution must be root 8t. This we have to prove. So let us start with the sum, students. So let us start with the sum. Here distance, when distance r, period of revolution is given t, but according to Kepler's third law, we know that t square upon r cube is equal to k. T square upon r cube is equal to k. So I'll change the side of this k. K will go in denominator when it will go that side, and r will come this side and it will come in numerator. And our equation, I'll write the same equation over here, students. Here this equation I'll write here, t square upon r cube is equal to k. So here what I'll do, I'll change the side of k and I'll change the side of r cube. Sorry, I'll not change the side of k, I'll just change the side of r cube only. I'll not change the side of k, I'll just change the side of r cube. So we'll get t square is equal to k r cube, students. So here I'll repeat again here, students. What I'm doing, I'll just copy the second step. Here we are having t square upon r cube is equal to k. So here t square upon r cube is equal to k. I'll just change the side of t square upon r cube is equal to k. I'll just change the side of r cube. We'll get t square is equal to k r cube, students. K r cube. So this t square is equal to k r cube we have written over here. Now period of revolution, we got t square. Here we got t square is equal to k r cube. We'll take square root, students. This square, when this square will go that side, it will become square root, and we'll get t is equal to under root k r cube. Now according to question, when r is equal to 2r, when distance is equal to 2r, distance r, instead of r will take 2r. So here in bracket, instead of r will take 2r. So here it will become t is equal to under root k will remain as it is, and r, instead of r it will become 2r cube, students. Instead of r it will become 2r cube. I'll repeat again, students. Here the same I'm writing over here, students. T is equal to under root k r cube, students. Now here instead of this r we'll write 2r, students. Instead of r we'll write 2r. It will become 2r cube, students. 2r cube. Same thing is written over here, students. This is cube. Now when you will open the bracket, it will become under root k as it is. Here 2 cube, 2 cube will become 8. 2 cube is 8, students. So k as it is, 2 cube will become 8, and r cube is r cube, students. R cube is r cube. Here root 8 I'll write separately, and under root k r cube separately. Here under root k r cube is nothing but t, previous t, students. So here we got root 8t, root 8t. So this is what we wanted to prove. The period of revolution will become root 8t, students. Root 8t, we got root 8t here. This is the proof. Very simple one, and hardly 4 to 5 steps are there and no theory. So it will be easy for you to solve this sum. Let's move ahead. We'll see the second sum. When we'll see second sum, object takes 5 seconds to reach the ground from a height of 5 meter on a planet. What is the value of g on the planet? Here, students, distance is given 5 meter and time is given 5 seconds. Here, students, time 5 seconds and distance is given 5 meter here, students. So initial velocity, when any object starts falling down from a certain height, initial velocity is always 0, students. Initial velocity is always 0. Initial velocity is always 0. Here gravitational acceleration g we have to find. Now what we will do, we will use the formula s is equal to ut plus half gt square, students. Here this is the second law of motion. This is the second law of motion. Just there is a small change. Instead of a g is written over here, students. A, instead of a, g is used. Why? Because here acceleration is due to gravity. So this formula we are going to use. Now in this formula, students, this formula we have already learned when we were doing gravitation part 3. So please, if you want, you can revise it from gravitation part 3. At present we are going to use this formula. S is equal to ut plus half gt square, students. Now here we will put the values. U is 0, students. So ut will become 0. U is 0. Here when you can see u is 0, so ut will become 0. First term 0. Here s is equal to 5, students. So here we'll take 5. Half as it is. G value we have to find. G value we have to find. And t is again, t is 5. T is 5. So it will become 5 square, students. It will become 5 square. So this is just a value we have substituted over here. All the values are substituted. Now phi, this first phi is as it is. First phi is as it is. Now this phi square is 25 upon 2. G is as it is. G is as it is. Phi square is 25 and 2 denominator I have written over here. I'll change the side of 2 and 25. I'll change the side of 2 and 25. I'll write it over here and I'll show you, students. Here we are having phi is equal to g into 25 upon 2. 25 upon 2. When we'll change the side of 2, students, when we'll change the side of 2, 2 will go in numerator as it is in denominator, students. So we'll get phi into 2. Phi into 2. When you will change the side of 25, it is in numerator, it will go in denominator and it will become upon 25. Here what is left is g, students. Now phi ones are phi and phi fives are 25. So we'll get 2 upon 5, students. We'll get 2 upon 5. Now when you will solve, when you will divide 2 upon 5, when you will divide this 2 upon 5, you will get 0.4. You will get 0.4, students. Sorry, students. You will get 0.4, and when you will divide 2 by 5, you will get 0.4, and this is the value of g on the planet. It will be 0.4 meter per second square. Let's see few more questions here. The mass and weight of an object on earth are 5 kg and 49 newton. Mass 5 kg and weight is 49 newton. Here what will be their value on the moon? assuming that the acceleration due to gravity on moon is 1/6 of that of earth. So gravitation on moon is equal to 1/6, 1 upon 6 into gravitation on earth. We know gravitation on earth is 9.8, so value is substituted. When you will divide this 9.8 by 6, you will get 1.633 students. So here we are having gravitation on moon. I'll repeat again students, I'll repeat again. According to the question, gravitation on moon is 1/6 of gravitation on earth. Now gravitation on earth is 9.8, so value is substituted. When you will divide this 9.8 by 6, when you will divide this 9.8 by 6, you will get 1.633 meter per second square. So this is our G value on moon. Gravitation on moon is 1.633 meter per second square. Now what we have to find? We have to find mass on moon and weight on moon. Students, first of all, mass is always constant. Students, mass is always constant, so mass will remain same as it is on earth. Moon also, on moon also the mass will remain same, it is 5 kg only. So mass on earth and mass on moon will remain same. Why? Because mass is always constant, mass do not change. Now we'll talk about weight. For weight we are having formula F is equal to mg. F is equal to mg. So weight on moon will become mass on moon into gravity on moon. Weight W is equal to mg. So weight on moon is equal to mass on moon into gravity on moon. Students, I'll repeat again students. Weight on moon is equal to mass on moon into gravity on moon. Here mass, I said to you, as I said to you, mass remains same everywhere. So mass will remain same 5 kg. So I'll put the mass value 5. G value we now saw that 1.633. It is 1/6 of gravity on earth. When we'll multiply, we'll get 8.17 Newton. This is the weight of the object on the moon, students. Now here mass on moon is 5 kg and weight is 8.17 Newton, students. Let's see one more question. Here when you will see one question is there, a ball falls off a table and reaches the ground in 1 second, assuming g is equal to 10 meter per second square. Calculate its speed on reaching the ground and the height of the table. Here given time is 1 second, students. Time given over here is 1 second and g is 10 meter per second square, students. Sorry, 10 g value is 10 meter per second square. Now initial velocity u is equal to 0. Whenever any object falls from height, initial velocity is always 0, students. Now we are having two formulas. V is equal to u plus gt and s is equal to ut plus half gt square. So to find v velocity, we'll use first formula, and to find displacement s, we'll use second formula. So v and s we have to find, students. So let us start with first formula. V is equal to u plus gt. Same formula is written over here. Initial velocity is 0, students, so u value is taken 0. G is given 10 here. G is given 10, students. You can see g value is given 10 and time t is given 1. T is given 1, students. So same values are taken. When you will see, first term is already 0, students. First term is already 0. 10 into 1 will become 10. So velocity is equal to 10 meter per second. In the same way, we are using second formula now. In second formula, when you will put the value of u is 0, first term becomes 0. So here s is written as it is. First term becomes 0 as u is 0. Half is written as it is. G value is 10, so 10 written, and t square. T square is 1 square as t is 1. So when you will solve it, students, when you will solve this equation, first term 0, no need to consider. 2 ones are 2, 2 5s are 10. So here 5 into 1 square is 1, will get 5. So displacement is 5 meters, students. Let's continue. When you will see the next sum, here the mass of the earth and moon are 6 into 10 raised to 24 kg and 7.4 into 10 raised to 22 kg respectively. It is given. The distance between them is 3.84 into 10 raised to 5 kilometer is given. Calculate the gravitational force of attraction between them. Here we can see that the mass of the two objects are given and that distance between them is given. So we can use the universal law of gravitation formula. First, let us write whatever is given. Mass m1 is given 6 into 10 raised to 24, 6 into 10 raised to 24 students, and the weight second mass m2 is given 7.4 into 10 raised to 22. Mass of the two objects. The distance between them r is given 3.84 into 10 raised to 5. This kilometer is converted into meter. 10 raised to 5 will become 10 raised to 8. Kilo means 10 raised to 3 students. Kilo means 10 raised to 3. When you will see 10 raised to 5, I'll write here, I'll show you 10 raised to 5 kilo. So it will become 10 raised to 5 into 10 raised to 3. Here base 10 is same, so we'll add 5 plus 3, it will become 10 raised to 8. That's why here it is written 10 raised to 8 students. It will become 10 raised to 8 meter. This is r value. G value is very known to us. I have already shown this G value to you. I have taught you in previous lectures. So here you will remember 6.7 into 10 raised to minus 11 Newton meter square per kg square students. So see, this is the G value. Now formula we know, F is equal to G m1 m2 upon r square. This is the universal law of gravitation. Here we'll substitute all values students. F is equal to m1 m2 m1 first one is G value is there 6.7, m1 value is there, m2 value is there, and here r value, and r value is taken in square because r square is there in formula student. So here value is substituted, nothing more than that. So there should not be any confusion students. Here F is equal to G, capital G, m1 m2 and r square. So values are substituted. Now what they have done, they have multiplied 6.7, 6 and 7.4. when you will multiply all three, you will get 297.48, 297.48. What is left here students, 10 raised to 20. Just a second students, just a second. Here what I did, you must have understood that I have just multiplied 6.7, 6 and 7.4. I'll get 297.48. You can multiply and check students. Now later what we'll do, 10 raised to minus 11, 10 raised to 24 and 10 raised to 22. Here 22 plus 24 will become 46. 22 plus 24 will become 46. 46 minus 11 will become 46 minus 11 will become 45. We can do it. Here they have not done, they have just copied as it is, they have copied as it is, and down here 3.84 into 3.84 is 14.74. I'll repeat students, I'll repeat again. Here when you will see, here 6.76 and 7.4 are multiplied, written as it is, multiplied and written answer here. 10 raised to 11, 10 raised to 24 and 10 raised to 22 is written as it is. Now 3.84 is multiplied, 3.84 into 3.84, square is there, so taken square, multiplied 3.84 into 3.84, and we got answer 14.74. Now 8 raised to 2, 8 into 2 16, so 16 is written over here. Now I'll tell you what to do. Here what they have done, they have taken approximate value students. Here approximate value is taken, 297.48 is approximately 300. In the same way 14.74 is approximately 15. Now here students, 22 plus 24 is 46. 46 minus 11, 46 minus 11 is 35. 35, 10 raised to 35, up it should be 10 raised to 35, and when you will see down, it is 10 raised to 16. So out of 35, 16 is cancelled. Out of 35, 16 is cancelled, 19 is left, 10 raised to 19. And here 15, 2s are 30, so you will get 2, 0. 20 into 10 raised to 19 is our answer. So force is equal to 2 into 10 raised to 19 Newton. So students, for today, I will stop my lecture here only. and this is the last lecture of your gravitation. Thank you for attending my all the four lectures, all the four videos. Next time what I'll do, I'll first make the video of a full gravitation chapter, and you will get a full gravitation chapter in a one video, and you will able to revise it, students. And later we'll continue with the second chapter, that is periodic table. Thank you, students. Thank you very much.